Hello, geometry folks. This is Mr. Heeren, and we are looking at the very end of Unit 6. That should be 6.7, not 7.7. And we're talking about the law of cosines. So previously we talked about the law of sines, okay? Now we're going to talk about the law of cosines. There is no law of tangents, for those of you that might be wondering. So it's law of sines, law of cosines. And we're going to use this to kind of solve the missing parts of a triangle. Now, much like the law of sines, okay, this works on any non-right triangle, okay, non-right triangle. So, right triangle, you've got the SOHCAHTOA stuff, SOHCAHTOA stuff, all right. Then for non-right triangles, you've got law of sines, and now law of cosines, okay? So any non-right triangle is going to be law of sines, law of cosines. So here's where it's different than the law of sines. Law of sines, if you remember, I said you needed an opposite side and the opposite angle. You needed to know those. So if I look over here, law of sines, I needed that angle and the opposite side, angle, opposite side. I needed that to work, okay? I needed that to work. Here, I need, for law of cosines, I need two sides and the included angle. Okay, I need two sides and the included angle, or I can figure it out if I know all three sides. Okay, so I need at least two sides and one included angle. Okay, so I still need a little bit of information. So it's going to be one of these things. Okay, so again, non-right triangle. If I have an angle and the opposite side, I can do law of sines. If I have this situation, that's where law of cosines comes into play. So basically, if I don't have this, I'm trying to use cosines. Okay, so law of cosines says this. Okay, one side squared is equal to the other two sides squared added together. So this is a little bit Pythagorean theorem to start, almost. Okay, so a squared is equals to b squared plus c squared. But then I've got to do a little bit more work, because remember, Pythagorean theorem only works on a right triangle, so it doesn't totally work there. Minus double bc times the cosine of its opposite angle. So let me say that again. One side squared is equal to the other two sides squared and added together, minus double the product of these two times the cosine of the included angle. Okay, so now there's a little bit of remembering here. There's a little bit of setup here. So let's look at an example of kind of what we're talking about here. So I'm trying to find BC. I'm trying to find that length right there. Okay, I've got two sides and the included angle, so I can use law of cosines. Okay, so we will call this A. So now it's a squared equals b squared plus c squared minus 2bc times the cosine of A. Okay, I merely just borrowed this one up here. But now let's kind of fill in the blanks here and do some substitution with what I know. So I'm looking for a squared, and I'm just going to say, okay, this is 21 squared plus 42 squared minus 2 times 21 times 42 times the cosine of 39 degrees. All right, this is what my angle is. That's the angle I'm using. Okay, now, once I have this, it's some calculator mashing, but I have to be careful. Don't put all of this in the calculator at once. Okay, don't just expect your calculator to do all of that for you in the correct order for this entire thing. Okay, your calculator's not always gonna follow order of operations. So 21 squared is 441. 42 squared is 1764 minus 2 times 21 times 42 times the cosine of 39. Okay, I can kind of multiply all this together. That's going to be 1370.89. So now I can add this and subtract, and I get 834.11. Please don't leave it like that, okay? Please don't leave it like that. Technically, this is incorrect. Many students forget that that's what a squared is. And if you take a moment, think about it, you know, this side is 21, this side is 42. So if this side is 834.11. No, that makes absolutely zero sense. Okay, I've got to take one final step and take the square root of that. So that becomes 28.88. This answer makes a lot more sense in the context of the problem. That makes a lot more sense. So here's all I did. Substituted what I know, the other two sides, and the cosine of the angle. Okay, and then it's just some calculator mashing, some order of operations, some evaluating. Finally, take the square root, and I'm done. So now, if I look at this one, similar, okay? So I've got 26 degrees. I don't know what B is, but I do know what the other two sides are. Okay, there I can work. Now I can work. So in this case, B squared, well, it'll be A squared plus C squared minus double AC cosine of my angle. All right, so I'm looking for B squared. So it's really just the other two sides, 18 squared plus 26 squared minus double 18 times 26 times the cosine of my angle. All right, for those of you that are haven't quite figured out, you are looking, a lot of this is set up. And like 95% of this is making sure you have it set up right. The other 5% is following order of operations correctly. So 18 squared, 324, 26 squared, 676, 2 times 18 times 26. And again, I'm just calculator mashing here, basically. Minus 841.27. So now I'm going to put all this together. So B squared equals 158.73. Square root, square root. So B is going to be equal to 12.59. 12.6 is acceptable here. So I would call that 12.6. And then, you know, does that make sense? I think it does. That works for the context of the problem. 12.6 is a perfectly acceptable answer there. Okay, so here on this one, figure out the length of A and B. But this one, if you notice, I've got an angle and the side across from it. So this one I'm actually going to use law of sines. Okay, so I'm going to figure out two things. Okay, so first thing I'm going to figure out B. So I'll have sine of 38 over 12 equals sine of 85 over B. Do some cross stuff. Okay, 12 times sine of 85 equals B times sine of 38. All right, so 12 times sine of 85 is going to be about 11.95. Then I'm going to divide both sides by the sine of 38. So if I just divide by sine of 38, I get B to be equal to 19.42, which is fine. 19.42 is that one. So now how do I figure out A? Well, before I figure out A, I really need to figure out how big angle A is. So to solve for A, well, I need to figure out that A is going to be equal to 180 minus 38 minus 85. Remember, still a triangle. All the angles have to add up to 180, so I can use that fact to help me figure out that angle A is going to be 57. Okay, so now I'm going to use this again. So I'll go sine of 38 over 12, that one I know. And the other one I'm doing is sine of 57 over A. So now, boom, boom. So 12 times the sine of 57 equals a times the sine of 38. So a little division by sine of 38. So I'm going to take 12 times sine of 57. I figure hit enter. That's approximately 10.06. So then if I divide that by sine of 38, that's going to be 16.35. There's my answer right there. And those two I think fit. Those two I think are perfectly well within the terms of this triangle. Those are acceptable lengths. I don't have anything completely outrageous. Okay. So let's take a look at here. We want to find E. So we're back to law of cosines. We're trying to figure out E. Well, we know that E squared is going to be equal to 6 squared plus 18 squared minus double 6 times 18 times the cosine of 88 degrees. So now this is just a lot of order of operations. Okay, so 6 squared, 36. I don't know why I put the equal sign there. That does me no good. 18 squared is going to be a good size number, 324. All right, 2 times 6 times 18. And I can kind of just mash all these things together. Cosine of 88 is going to be 7.538. So now I do that, and I get an answer of 352.46. Remember, that's E squared, square root, square root. So my answer is just going to be merely 18.77. Okay. That is going to be my answer, and that's acceptable right there. 18.77. Okay. Good. Now, let's take a look at this one. Yes, the dreaded word problems. Things you got to start organizing in your head. I understand. 2 ships are sailing from Halifax. The Nina is sailing due east, and the Pinta is sailing 43 degrees south of east. After an hour, the Nina has traveled 115 kilometers, and the Pinta has traveled 98 kilometers. How far apart are the ships? Okay, so we'll call this Halifax. Okay. The Nina is sailing due east. Okay, so there's the Nina. And after 1 hour, it has traveled 115 kilometers. The Pinta is sailing 43 degrees south of east. So the Pinta is going this way. And it has traveled 98 kilometers after an hour. And we know it's sailing 43 degrees of east. Now it's asking how far apart are the 2 ships. So what's that distance between the 2 ships? So this is very, very much a law of cosines problem. Okay, so we will call that little h. So little h squared is going to be equal to 98 squared plus 115 squared minus double 98 and 115 times the cosine of 43. So now that is your setup. Okay, and if you're not sure kind of where I got something, so if this is due east, 43 degrees south of east is going to be my angle. Okay, so due east, then you go 43 degrees south, that's going to be my angle, and that's kind of what set me up here. So 98 squared is 9604, 115 squared is 13225. Minus 2 times 98 times 115 times the cosine of 43, all mashed together. That's 16,484.71. So now I do some adding and some subtracting. So I get h squared to be 6344.29. some square rooting. H is 79.65. So how far apart are they? They are 79.65, or approximately 80 kilometers apart. Okay. Okay, I think that's pretty good. So, I mean, like I said before, 95% of this is going to be setting this up correctly. The other part is going to be following order of operations correctly. All right, it's a good little problem. Okay, so now you're doing your assignment. Make sure that you are getting 100% on the quizzes. And then you are working on the Unit 6 review and trying to take the Unit 6 test. Okay, I look forward to your questions. We'll talk to you soon. Bye-bye.